Hello learners, just if you want to consider the carrying out of a practical session or carrying out of a physics experiment. So today we're going to conduct a practical session of physics experiment. So when conducting a practical session, the title of the experiment is very vital. Title of the experiment. So our title of the experiment is written in this experiment. You will investigate. You will investigate the oscillations of a loaded multi-spring system. That is the title of the experiment, right? After having started on the title of the experiment, the next step is to consider the experimental setup, right? So this is the title of the experiment that we're going to conduct. So in every lab session or practical session or experiment, there's the title of the experiment. So in this experiment, you will investigate the oscillations of a loaded multi-spring system. So the next thing that we want to consider is the experimental setup. The experimental setup. Experimental setup. Set up the apparatus as shown. Set up the apparatus as shown. As shown in figure 1.1 with initial mass m, with the initial mass m of 100 grams. So the setup is as shown. This is how the setup is written. This is basically the experimental setup. So our setup comprises of a stand and a clamp, the loaded multi-spring system. So we can draw the diagram of an experimental setup. We can draw this diagram of the experimental setup. The mass, which is 100 grams, the spring there, a beam, a simple beam there, this is supported there, another spring there, stand and a clamp, or stand, there's a G-clamp, but you cannot necessarily use a G-clamp. You can balance our stand using some other means, there's no problem, right? So we can draw the diagram of the experimental setup, right? So this is the diagram of the experimental setup. 100 grams. So we can do this experimental setup, right? Already there's a stand and a clamp there. So I'm going to put this there. Right, can you see? The spring there. Another spring there. Another spring there. Here's the experimental setup. Then the mass there. Right? So you can basically shift everything. Allow for an open venue. You can bring this there. You can shift this. Right? This is our experimental setup. So after having done the experimental setup, there are certain instructions that you must follow. So whenever you are doing an experiment, you must follow the instructions. Such as the experimental setup. Right. This is a mass of 100 grams. The next instruction is slightly displace the mass M so that it performs oscillations in a vertical plane. Right. What are oscillations in a vertical plane? So if we displace this, you see it is performing oscillations in a vertical plane. This mass is oscillating, right? Can you see it? So this is exactly how you are going to obtain your observations. So this mass should perform oscillations in a vertical plane. Right? That is the next instruction. That was the instruction. Then the next instruction is saying make and record measurements. Make and record measurements to determine the period T of oscillation of a system. This instruction is very, very important. Make and record measurements to determine the period T of oscillation of the system. Already, we've got an oscillating mass M, right? It is performing a certain number of oscillations. Time for one complete oscillation is a period. So you can measure the time T for a certain number of oscillations. Right? Right? period T is the time for one complete oscillation. So T is equal to n times certain number of oscillations. You can have T for a certain number of oscillations. So T over n, T over number of oscillations, you get T, right? So this one, which brings us to T is equal to n T. So you can measure the time for 10 oscillations. You can have T is equal to 10 T. This is time for 10 oscillations. So T1, if we do it for the first instance, we have 10 T1. For the second instance, we have 10 T2. So if we want to average T average, then it means we have 10. This will be like this. So one of the instructions which was saying, make and record measurements that around the period T of oscillation of the system. It will enable, it should enable us to come up with this instruction. There's this instruction which says, make and record measurements. Make and record measurements to determine the period T of oscillation of the system. Of oscillation of the system. Period T of oscillation of the system. Oscillation of the So remember we've got mass M, this oscillating mass, a vertical plane. So this mass M is in grams. So we are going to have a column for mass M. Then we said we should have T for 10 oscillations. So we are going to have T1, or we can express it as 10 T1, right? Then I'm going to have 10 T2. So before, let's suppose this mass is 100 grams. So we should have 100 grams and measure time for 10 oscillations. Measure another time for 10 oscillations. Then we should average this. Right? We should average this. Right? Now let's move on to the next instruction. Let's move on to the next instruction. The next instruction says, I'm not going to wrap this table, but I'm going to move on to the next instruction. Increase the mass M for M in the range. Increase the mass M for M in the range 100 grams less than or equal to 600 grams, and repeat the first three instructions to obtain 6 sets of readings. And repeat So already we've set up the apparatus, we've set up this. Want to observe oscillations in a vertical plane, right? So we can actually measure time for 10 oscillations for 100 grams. For the first time, so it's 5,50 again. Okay, let's measure. Nine, 10. 5,38 seconds. Right. So this is called draw dart. But this instruction, the fourth instruction is saying increase the mass M, the mass M for M in the range 100 and repeat the first 3 instructions. So the repetition of first is simply this experimental setup, the measurement of time for 10 oscillations, right? Static displacing, right? Static displacing and measurement of the time for 10 oscillations. To obtain 6 readings. To obtain 6 readings. So it means our table should have a mass of, because the range of M should be from 100 to 600. So our table should have 200 there, 300 there, 400 there, 500 and 600. So now our table has got all the masses for which we should measure 10 T1 and 10 T2. So we should be within the range. We should be within the range. So we should be within the range. In the table of results include values for M, log M and log T. Right. Next instruction is that in the table of results, in the table of results include values for M, log M and log T. Already we've got M in grams, so we should include log M. Okay, M is in grams, right? Like this, log T in seconds. So we should have now this is now a complete term, right? So we are following the instructions in this practical session. We are following the instructions. So now our task, we should also measure for 200, for 300, for 400, for 5, for 600. Measure time 10 T1, 10 T2 for 200, for 300, 4, 5, and up until we have reached 600. So you can rewrite this table there. You can rewrite the table. So remember our table, there is M, there in grams, 10, so this is M, 10T1, 10T2, 10T3, then we should have a column for T. I have not put a column for T there. Remember, T, so this is in seconds, 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 seconds. Then we should have log M then grams, log T then seconds. So this is 100 grams, 200 grams, 300, 400, 500, and 600 grams. So you can start afresh and quickly take all the raw readings. So we can measure 10T1 for, so log M brackets M over gram, log T brackets T over seconds. But log are the numbers of a constant number. So if it is like if say log 100 grams over grams, you cancel the grams, then we will remain with log 100. If we have time 10 seconds, so much seconds over seconds, they cancel. So we have log arithmetic of a Q now. So we're going to measure the time for 10 oscillations, which corresponds to 100 grams. Then we repeat again. Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 5,47. And can redo again. Oscillations have to be stable. 0, 1, 2, 3, 4, 6, 7, 8, 9, 10. Actually, let me redo this. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 5,38. Let's repeat and make for 200 grams. So this mass is 100 grams, this is 100. So this and this mass and the here is 100 grams. So this is, so I'm adding one another 100 to make it 200, right? So it will be 200. Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 7,63. So are you doing again? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 7,60. Then we should redo for 300 grams. Ten. going to redo again for repeat again. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And comma 0, 9. Redo again for 400. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, 5, 9. Redo again. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, 5, 6. Redo again for 500. Do again for 500. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 6, 9. Repeat again. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 7, 8. Right. Lastly, we should do for 600. So 1, 2, 3, 4, 5. So I'm now doing for 600. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 12, 88. 12, 88. Then I'm going to repeat again for 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 12, 81. The reason why I am repeating the measurement of time for 10 oscillations for each mass is so as to minimize random error. We're doing this so as to minimize random error. So we're going to average. Want to measure, calculate the average. We complete our term. So it will be 5,47 plus 5,38 divided by 2. It will be 5,425. Right? 5,425 divided by 10. 0,5425. Then log of 100. Log of, it will be 2, so for log, number of significant figures there is 3. The number of decimal places would be 3. Right? Then for log log 0,5425 to minus 0,2. So here there are 4 decimal places. So in the log there should also be 4 decimal places. So it's minus 0,2656 minus 0,2656. Right? Then 7,63 plus 7,60 divide by 2, should get 7,615. Right? So 7,615 divided by 10, 0,7615. 0,7615. Logarithm of 200. Logarithm of 200, what you get? 2,301. 2,301. So here there are three significant figures, then there should be three decimal places. Then logarithm of 0,7615 is minus 0,1183. Minus 0,1183. Then 9,13 plus 9,09 divided by 2, 9,11 is the average. Then divided by 10, 0,911. Then logarithm of 300, 2,477. 2,47. Here there are three significant figures here, so there will be three decimal places in logarithm. The logarithm of 0,911 minus right. Logarithm of 0,911 is minus 0,04. Minus 0,04. So there are three decimal places, so there are three significant, so there should be three decimal. So it's 0,40 there. Right? Then 10,59 plus 10,56 divided by 2, 10,575. 10,575. Then divided by 10, 1,0575. Logarithm of 400, 2,602. 2,602. Here there are three significant figures here, so there should be three decimal places. Then logarithm of t log 1,0575. 0,0243. 12345. So it's 0, so there should be 5 decimal places. 0,0248. Right? Then 11,69 plus 11,78 divided by 2, 11,735. Then I'm going to divide by 10 there. 1,1735. Logarithm of 500, 2,699. 2,699. So three significant figures, three decimal places. Then logarithm of 1,1735, logarithm of t. Logarithm of 1,1735, 0,0694, 0,069. So it's 1, 2, 3, 4, 5 decimal places. 5 significant figures, so there should be 5 decimal places. 1, 2, 3, 4, 6, 9, 4, 8. Right? 1, 2, 3, 4, 5, right? Then 12,88. 12,88 plus 12,81 divided by 2, 12,845. That is the average. Then divided by 10, what we get? 1,2845. 1,2845. Then logarithm of 600. 2,778. 2,788. It's 2,778. Then logarithm of 1,2845. 0, so it's 1, 2, 3, 4, 5 significant figures, what decimal places. So it will be 0, 10, 10873. 10873. Right. That is our complete table. So all the row readings there they must be correct. All the row readings must be correct. All the row readings must be correct. So I have to take the very important readings from there so that I'll proceed to process. So this is called raw data. This is called raw data. So this table is very, very vital when doing an experiment. So you should have a complete table. So this is my complete table. For 100, I should take this and that. So this is the raw data. Right? So want to process this raw data. The next step is to process this raw data. Right? Processing of the raw data. We're told that according to theory, according to theory of this experiment, according to theory, it is suggested that T is equal to beta M to the power alpha, where alpha and beta are constants, right? Where alpha and beta are constants. 1 plot a graph of log t on the y-axis, right? Against log m x axis, right? To use the graph to determine the values of alpha and beta. So, according to theory, it is suggested that t is equal to beta m to the power alpha, then where alpha and beta are constant. So, we have to plot a graph of log t against log m. So, why are we plotting a graph of log t against log m? Let me explain. Why are we plotting a graph of log t against log m? So, t is equal to beta m to the power alpha. So, this is because log t will be equal to log beta plus log m to the power alpha, which becomes log t is equal to log beta plus alpha log m. So this will be on the y-axis, this will be c, alpha will be m, this will be on the x-axis. So log t will be on the x-axis, log m will be on the log t will be on the y-axis, log m will be on the x-axis, alpha will represent the gradient, intercept c will be represented by log b. So we're going to plot a graph of log t against log m. Right? When plotting a graph, so it means the graph we're going to have log t there, right? And then log m there in grams. Then we can have a false intercept. False origin, I mean to say. False origin. So our tape, the important result in the table that we're going to use to plot the graph. So we've got log t and log m. So 3, 4, wait. Minus 0,2656, and the corresponding there was 1,00. Then we had minus 0,1183. Corresponding value was 2,301. So then we had minus 0,040, 2,477. 1, 2, 3. Then we had writing 0,02428. Then there was 2,602, right? finally we have 0,10873, then 2,778, right? So I'll compare the graph of log t, right, against the log n grams. So it means in this graph we have a 0 there for, so we should have minus 0,05, right? We can have minus 0,01, minus 0,05, minus 0,1, minus 0,15. So we should choose our scale. We should be able to choose our scale. So we have 0, minus 0,05, minus 0,10, minus 0,15, minus 0,20, minus 0,25, minus 0,30, right? So because you should use the whole axis. Then we have 0,05, another 0,05 there, 0,1, right? And then we have another 0,15, right? So this is log t in seconds, right? Then for the horizontal axis, we should have 2 there, maybe 2,2, 2,4, 2,6, up to 2,8, right? So I'm going to do the actual graph and then show you. I'll do the actual graph. So this is the space over which you should draw a graph. This is the space. So here's our rule. So can you see? Right? So I should fill all the space with log t. So I'm going to label log t there in seconds. So 0, 0,05, 0,1, 0,15. So I should start here 0, 0,05, 0,1, 0,15, 0,2, 0,25, 0,3. So this is going to be 0, 0,05, 0, 0,10, 0, 0,15, 0, 0,20, 0,25, 0,30. So the first two divisions will be 0,01, 0,2, 0,3, 0,4, 0,05, 0,06, 0,7, 0,8, 0,9, 0,1. So here we have 2, right? The log there should be 2. You should have 2 there for log 100. So we have 2 there, 2,1, 2,2, 2,3, 2,4, 2,5, left 2 there, left 2 comma 2 there, 2 comma 2, 2 comma 4, 2 comma 6, 2 comma 8, right? So it means it will be 2 comma, so here the center will be 2 comma 1, right? There the center there is in there 10 boxes. So at the 50th box there it should be 2 comma 1. So we're going to plot this point. So we should look for 2 against minus 0 comma 27. This is the point here we are. Then minus 0 comma 118. So it will be minus 0 comma 12. We round off against 2 comma 3. Here I am, I have plotted this point. Then minus 0 comma 04 against 2 comma 477, which can be 2 comma 5. Minus 0 comma 04. Here is minus 0 comma 04. 2 comma 4. 4 2 4 4 4 6. This is 2 comma 2 4 6 8. 2 comma 1, right? So you should be able to interpret your scale. So I have plotted this point. Minus 0 comma 04 against 2 comma 477. Then move on to 2 comma 6 and 0 comma 02. So this should be 0 comma 05, 0 comma 10, 0 comma 15, 0 comma 20. So 2 comma 6 against 0 comma 02. 0 comma 01, 0 comma 02, here I am. 2 comma 7 against 0 comma 069, which is against 0 comma 07. 2 comma 7. So here's my 2 comma 7, 0 comma 06, 07. Here I am. 2 comma 7 against 0 comma 07. Then 2 comma 7 8 against 0 comma 11. So 6 2 6 4 6 6 6 8 2 comma 7 7 2 7 4 7 6 7 8 2 comma 7 8 against 0 comma 11. This would be 0 comma 11. So can you see all these points has been plotted, right? So we should choose more than half the scale, then more than half. So I'll draw my line of best fit. This is my line of best fit, right? This is my line of best fit. It is balancing the scatter loop. There is this point which is aside. Almost the 3 points are on the same line. 1, 2, 3, 4. In that point. So this is my line of best fit. It all depends on how good are you at precision and accuracy. Right? So we've plotted a graph. You see log T. So when plotting a graph, make sure like here it's log M over gram. So I've labeled exactly like I've labeled on the table. Log T over second. So I've labeled log T in brackets over second like I've done. Make sure that all the points are plotted. Use more than half the scale there, more than half the scale there. Plot your points accurately. Choose a convenience scale like here 0, 2, 2,2, 2,4, 2,6, 2,8 is a convenience scale. So you should be able to interpret your scale and it should be uniform. Minus 0, 0,05, 0, 0,1, 0,15. This is a uniform scale to accommodate all these values of log t. And all whatever. So you should use more than half the scale on the x-axis, more than half the scale on the y-axis. Now moving on to analysis. So after having plotted the graph, I should read off 2 points along the straight line graph, which I'm going to use as for calculating gradient. So these are the points I've read them off. Since I'm the one who plotted this graph, 2,2, 2,82, 8486 against 0,15. Then 2,2 against 0,567 0,175 0,1516 1718, so it's minus 0,175. So these points are going to be used to plot your target. So I'm moving on to the analysis stage. I'm moving on to the analysis. Can you see this graph? How it is plotted, right? Take a closer look. Right. So want to consider analysis. Analysis. So, in the questions under analysis, we have been asked 2 questions. Isn't we have been told that according to theory, t is equals to beta m to the power alpha. So log t is equals to log beta plus alpha log m, right? So we have plotted the graph of log t against the log m. So want to find beta and alpha. So y is equals to c plus mx. This is analysis. M is equals to alpha. C is equals to log beta. So we should calculate the gradient. So I'm going to use this graph to calculate the gradient and further use that gradient to deduce the value of alpha. Right? So how do we calculate the gradient? Already we should read off the values that we are going to use for gradient. So these are my values on the gradient triangle. I have 2,86, 0,15, 2,2, minus 0,175. So gradient is equal to delta y over delta x. So this is x1, y1, x2, y2. So we will have y2 minus y1, which is minus 0,175 minus 0,15 over, so y2 y2 minus y1, x2 minus, which is going to be 2, 2 minus 2, 86. Minus 0, 175 minus 0, 15, 2, 2 minus 2, 86. So so our gradient is 0,49. There are no units. 492. There are no units. Log T over log M. There are no units. So since M is equals to alpha, it means alpha is equals to 0,492. This is our gradient. So I want to calculate the beta of R. So this is our gradient. This is our gradient 0,492. So y is equals to mx plus c. So y is equals to 0,492x plus c. So we can take can employ any y value. We can take 0,15 as our y value and equate it to 0,492. And the 0,15 is there on the x-axis. So the corresponding x value is 2,86. Then we can deduce the intercept. So we can take any values along this line and plug them, the y value and the corresponding x value to get c. So we get 0,15 minus 0,492 times 2,86, which is minus 1,257. So c is minus 1,257. Right? So from log t is equals to log beta, if you remember very well, plus alpha log m. This means log beta, so we said y is equals to c plus mx. So this means log beta is equals to minus 1,257. So beta will be 10 to the power minus 1,257, which you can calculate. So second 10 to the power minus 1,257 get 0,055, which is 0,055. That is the value for beta. It has no units. Right? Basically, that is how we do every practical. Make sure that you've got a complete table. All the raw ratings are correct. You follow the instructions. You plot your graph accurately. More than half the scale for x-axis, more than half the scale for y-axis. All the points are plotted. Then you do your analysis correctly. That is how basically a practical is done. So in our next lesson, in our next video, we are going to start on a new topic under forces. So we'll be doing more practical sessions as we go, so that you gain more experience and you gain more exposure and doing these practical sessions. Till we meet again in the next lesson, thank you.